The previous video I still not upload in the e-learning, so later once I finish the class I will upload. Okay. So I think so not this one. This one. Previously we activity 1, right? We done with the activity 1, right? Okay, sorry. Actually this one. Okay. So so today we will discuss about the framework for computer-aided molecular mixture design. Uh, the step that we have to consider before we do the product design, right? Uh, this one is the flow, or we call it as the frameworks, okay, for molecular and mixture design. Okay. So framework for computer-aided molecular mixture design. Actually, for the computer-aided framework for molecular and mixture design, uh, we they have a 5 hierarchical steps. Okay, if you look at here, that the main framework is 5 hierarchicals. Okay, we start. Okay, first is the problem statement, a problem formulation. Okay, so here that the CAMD, we use a CMD lah. CMD is for the molecular. Alright, CAMD lah. Okay, CAMD. Okay, and CAMD. SCM, there's a small b. This one is for blended or mixture lah. Okay. Okay. So the problem for CMD and CMBD, okay, we define in terms of the product needs and function. So we have to identify the goals of the design operation. This is the main things. Okay. Problem formation. For example, you want to design the, what is it? The lotions. Okay. The main thing is to find uh, the product that can, when we apply to the skin, it is not irritating. That is one of the goals, the main goals. Okay, or you want to design the water purifier. What is the main goals? Is it to filter? Maybe you want to remove the organic, to find the filtration or filter that can remove both organics and metal ion from the water. Okay, that is the main goals. Okay, or the problem formulation. Okay, and then the next step is the method and constraint selection. Okay, so the needs and function of the products are converted into specific set of the properties together with their target values. Specify the design criteria based on the problem formulation. Okay, so this is the next step. Okay, so first hierarchical, second hierarchicals, and then the next step is a CAMD CMBD solution. Okay, so either turning either CMD or CMBD. Okay, for examples like group contribution based technique. Okay, so we can generate and test candidate use. Okay, so in this step we have to identify the compound having that the desired properties based on the problem formulation. Okay, so at this step we the CMD or the software should able to generate molecular structure. Okay, and evaluate their properties. Okay, with respect to the specified target properties lah, that we already defined. Okay, and then the fourth step is a result analysis and verification. Okay, so here this step is the selected candidate, okay, from the CMD solution. Okay, further analyze to confirm their desired tools. Okay, so the final one is candidate selection. Okay, so here the detail for verification using the combination of the experiment as well as rigorous model based test, meaning that by using the rigorous simulation, uh, we confirm by using experimental. Okay, and then finish. Okay, so if you look at here, this is the arrow which is look at it's like a loop. Okay, if not suitable solution performance, so we cannot go to the next step, so we have to return. Similarly also for this one, right? If not still identifies, okay, this is if promising candidate have been identified. If not promising, we have to start from the problem formulation. Okay, so meaning that there's a loop here. Okay, if not achieve the targets or achieve the goals. Okay, okay. So let's see the example of the application of a framework for the CAMD. Okay. So for example, this one is the objective, the main objective. Okay, the main objective of the problem formulation. Step one, step one. Okay, this one. Okay, this one. Oh, the main goal to find environmentally friendly substitute molecule for benzene. Okay, so actually is benzene is carcinogenic, right? Okay, toxic to the human and also environment. Okay. So we have to find the substitute that can replace the benzene. Okay, environmentally friendly. Maybe it's the compound. The compound maybe we can what is it? We can assume or we can do the hypothesis likely to be the acyclic molecules, which is content of the CHO lah, because benzene is an organic component. So must be C, H, and also O. This one. This is the atoms. So must be also organic because benzene is organic. You can replace with the organic component also. So meaning that I want this acyclic alcohol, ketone, aldehyde, and ether, and with the salt properties. Okay, from this one, you can set the building blocks like a CH3, CH2, but CH2 is not stable, right? Okay, so we can combine later. Okay, this is just a building blocks. Okay. So we have to set this one CH, O, OH. This is the possibles with the functional. Some is the functional, can be functional group, can be the base of the building block. And also we set with the constraint to generate the candidate molecules. This one set of numerical constraint. Okay. Okay. Since same group vector may represent more than one molecule. Okay. All molecules are generated and evaluated using property models. So this one we can collect based on the vector 3CH3, 1CH2, 1CH, 1CH2O. Okay, so this is your collection. Okay, and then we can match. Okay, all group vector and satisfying with the constraint. Constraint is the boundary, meaning that how many, for example, you want to design like a propane, how many CH3? Okay, CH3, 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 CH2, CH3, propane. Okay, if there is alcohol, propanol, CH2, CH3, CH2, CH2, OH, meaning that one CH3, two CH2, and then one OH. But currently we are still not decided what compound that can replace the benzene. But we have a boundary which is acyclic, alcohol, ketones, and aldehyde. Acyclic is a linear change. Okay, is linear change, not the in term of like this one molecule. The ring. Okay, like this one. Okay, so that acyclic must be linear. Okay, and then the next level is a pre-design design, and then we have to go to the design higher level. For I think is for this course, I think we only cover from step 1 until step 4. Here, we not go here. I think. Okay, this one is we considering the isomer. Okay, so here we are distinguish some isomer. Okay, for example, this one maybe propanols, iso and propanols, right? Okay, so we do the screening. So this one is we use a group from the other GCA methods. Okay, refine property estimation, ability to estimate the additional properties. Okay, risk screening against the constraints. Okay, then start the post design. This is a step 5. So if some is not within the goals, so we have to at the this one, right, design analysis, we have to start from the problem statement again. Okay, we have to identify. Okay, so until step 5, this is we have to validate by using the experimentals. Okay, so the design process actually is start with the definition of the basics need lah, or the ultimate goals. You have to remember that the step 1. Okay, so actually the goals may be influenced by many the design decisions. Okay, maybe we during the phase of CMD problem solution. So we isn't that doesn't mean that we can get the exact goals. So that's why we have to they have a look that one. Okay. Okay, if you look at here that design process start with the definition of the basic needs. Okay, type of goal influence design decisions need to be made in the latter phase. This is during the CMD problem solution. Okay, this is the later stage. So the goal should describe first is a function of desired product, chemical product. What is the function, main function? Like a water, right? Water purifier, it should be filter the pollutants, okay, or air purifier, right? So we have to filter or remove the pollutants, okay. Environments or equipment where the function should be performed, okay, and capability that are desired or undesired lah, okay. So for example, in case of the design of the solvent, okay, if you want to design the solvent, must be dissolved, a specified solute, must be selective if other soluble solutes are also present, and must not cause a negative environmental impact, and also should easy to recover. Okay. So that is the example if you want to design the solvent. Okay. For example, if you want to this is in case of solvents. How about if you want to design the functional products like mosquito repellents? Okay, when you design the mosquito repellent, the main thing is what we call the solution, right? Okay, once we heat it, it can be evaporated. Okay, okay. So that is one of the example of the product. Before you design the products, the main things is, of course, it can repel the what is it, the mosquito. Okay, must be environmental friendly. Okay, and so on. Okay. Okay. So let's see the example of goal in CMD. Okay, removal of the phenols. Okay, this is one of the best examples because it's a well-defined problem. If you can hear that description goals of CMD can be of a different types. For example, find a solvent suitable for removing phenols or maybe other uh, pollutants lah, or metals in the river or from the wastewater, like a bisphenol A pharmaceutical waste, or what is it? Bisphenol A is one of the pharmaceutical waste. Aspirins, okay, from the wastewater, okay, from wastewater stream by liquid extraction. Okay, the solvent should pose a low health risk for the user. Okay, non-toxic or low toxic, should be environmental friendly, and could be a single molecule or a mixture. Okay, so this is a well-defined problem because all the necessary details are given, meaning that we have to remove the phenols using the liquid extraction. Okay, properties needed. What is the properties needed? because needs something that is qualitative. But how can we convert it or translate to the quantitative one? Okay, if you look at here, that since we want to use a liquid extraction, solubility is important. Okay, environmental friendly EHS properties. Okay, EHS properties later, maybe I can explain later in the next slide, I think, in terms of EHS, like toxicity. Okay, and this one is environment. EHS is environment, health and safety properties lah, like vapor pressure. Okay, flash point, VOD, right? What's that? Uh, Chemical stability or activity, that is EHS properties lah. And then liquid immiscibility and so on can be identified. Okay, so this is a properties needed, which is can be measured. Okay, goal value for properties are not given, but need to find best solvent. Then must higher solubility and least environmental impact. Must be least lah, the solvent, because we want to do the liquid extraction, right? Okay, so that is the goals value for the properties for this problem. Okay. Okay, another examples which is well-defined problems, identify a molecules with the same pure component properties as benzene. Okay, so meaning that we want to replace this benzene, such as a normal boiling point, a normal melting point. Okay, octanol water partition coefficient, solubility parameter that as that of benzene, but with much lower environmental impact in the workplace. Okay, this is a well-defined problem. Goals value given because the properties value of benzene are only. For example, last time when I did my synthesis of lignin from the biomass, okay, I have to replace dichloroethane or dichloromethane, because we when we want to discharge to the environments, it's a very low concentration, 10 ppm in when I did my PhD lah. Okay, dichloromethane and chloroethane. Okay, so what is the best solvent that we can replace is by using a chloroform. 10 ppm, if you use dichloroethane or 10 ppm is something like if you wash the what is it, the pipette, right? So we cannot wash in the sink. Okay, so even that one is already more than 10 ppm. Okay, even after the experiment. Okay, so usually in Japan, they can detect even very low concentration for each the pipe. They have something like storage to measure the pollutants, okay, discharge from every labs. Okay, so and then so we replace with the if I'm not mistaken, we use a chloroform, the less top, but with the same performance. Okay, okay, okay. So another one is solvent use for washing of an equipment. This is actually not very well defined. Okay, find a solvent to be used for washing of an equipment. Okay, which is environmental friendly and cheap. Okay, what should be dissolved by the solvent actually? Okay, we don't know. Okay, we don't even know. This not well defined. Okay, and the definition of the cheap, okay, actually is depending on, is ambiguous, right? Cheap is everyone can say maybe 1000 is cheap, 2000 is cheap. Okay, but it's depending on the process. Okay, so it's not very well defined. Okay. Okay, another example is also not very well defined. This one is the additive. Okay, find the additive molecules or mixture for a tape so that the tape will stick to the painted surface for a year, and then can be removed without pulling the pins. Okay, one of the non well defined. So we need more information about the glue. What type of the glue, right? Okay, what type of the glue? There are various composition of pins. Okay, in the pins. Okay, and then which properties are we looking for? Okay, so this is not well defined problems lah. Okay, And also another one's uh, not well defined, but we can solve. This one is about the inhibition activity. Just this one you can read. Okay. And another one is an isotrope. Okay. Usually isotrope we want to what is it to separate, right, to compounds, two components. Okay. So with the solvent. So this one we can solve by using CMD. Okay. Even I think uh, although it's not large space, but we can solve this one actually. Okay, by using CCMD. Okay. Okay. So the previous examples from the previous slide is actually highlighted the need for the knowledge and base system. Okay, that can identify the need properties from general problems. Okay. Okay. Once the properties or the goals can be identified. Okay. So so we can know lah the properties, okay, which is from the qualitative to the quantitative. Okay. So qualitative is a problem specification. So we have to uh, transform to the quantitative one. Okay. So how can we transform actually? As I told you, there's if you still know is qualitative is the qualitative is needed, or the main objective. The properties is something like we can measure. Okay. Actually, the qualitative problems consists of four problem specification. Okay. The quantitative problem specification consists of identify needed properties. Okay, this one. Identify goals value, and then method for obtaining properties value, and identify the building blocks. Okay, this is the what we call it as a identification from the problem specification, not the step items. Okay, when we want to transform the qualitative problem to the quantitative one. Okay, for example, the acidity, so we have to refer to the pH. Okay. Okay. So we have activity two, problem formulation. I give you about maybe 5 to 10 minutes. Okay. Given the list of products to be designed, write problem formulation which are considered well defined. Write in a paper, take a picture of it and submit in the actually this one Jamboard. Saya akan kasih Jamboard. Okay. Here are the list of the products. Okay. So I give you the link, the same link, the same link. I use the same link. I share again. So you can write directly to the um, Jamboard, a sticky note. Okay. So this is the link. So please do this activity. Okay. Here are the list. This is the example. Water purifier. Target to find the water filter that can remove both organic and metal ion from water. Okay, this is just an example like a previous one. Okay, problem formulation. What is the constraints? Okay, you also can add the constraint. I give you 5 to 10 minutes. So paste in the Jamboard. Please do now. So please do. It's almost similar like this one. This one. This one. Find the solvent. Something like that. Anyone? Please right now. I give you 5 to 10 minutes. No one? Right here. Letak kat sana. Kan tak ada yang tulis. Kosong je tu. Hand sanitizer, air freshener, hair cream. Ada 3. There are 3. So you can choose one of them. No need to write in, no need to take a picture, just directly using the, what is it? Sticky note. Okay, good. That's why. The solvent should be able to kill the germs present without causing any allergic reaction, okay, and irritation to the skin. How about freshener and hair cream and sanitizer? Okay, so meaning that for the hand sanitizer, this one, we want to find the solvent that does not cause any skin irritation, okay, to the customer, right? Kills the bacteria and then evaporate faster lah, after apply, right? Just like we use now, okay? So that we can kill the virus, okay? How about air freshener and hair cream? Saya panggil nama. Tadi siapa? Siapa mesej saya tadi? Nabila Syahira. Awak ada situ tak? Nabila Syahira. So can you do for the air freshener or cream? Air cream. Okay. To find the should be non-sticky after apply. What is should be non-sticky? Why is it? The solvent or why is it? Or liquid lah. Liquid should be non-sticky after apply. Not not cause any skin irritation. Okay. Hair cream ah. Hair cream. Okay. How about air freshener? Air freshener. The target is okay, to find the remove from odor without bringing harmful effect towards our lungs when inhalation. Okay lah. Okay. So this is good. Okay. So thank you very much. That's good. So let's we continue. Okay. So meaning that you understand the problem formulation. Uh, what is it? The main goal. Okay. The main goal. Okay. Sure. Okay. Let's see the methods and the constraint. Okay. Tak appear lagi. Appear already. Start, starting to share. Okay. So let's see the methods and constraint selections. Okay. So actually for methods and constraints, the objective of this step is to transform the qualitative problem, okay, specification to the quantitative lah. Okay. That should be suitable for the CMD problem solution. Okay, during the design phase lah. So as I mentioned previously, uh, the quantitative problem specification should consist of the needed properties or the behavior of the products. Okay. Uh, Identify the goal value of the needed properties. Okay. Identify the methods to for obtaining the properties values and identify the building blocks. Okay. For generation of the molecule structure candidates. Okay. This is what we can replace. For example, the solvent. Right? What we can replace the solvent. Okay. Kenapa tak keluar? Sorry. Okay. So how can we translate this product need to the target properties? Okay. So the objective we want to know we have to know the knowledge base lah. Okay. How can we transform this product need to the target properties? Okay. So first what we have to know is the need to have a knowledge base is to assist the transformation of general qualitative to the quantitative. Okay, there are much work need to be done to prepare the knowledge base. Knowledge base lah. First is we have to gather the information, okay, from the consumer, or we have do the survey lah. Okay, and then some additional needs know how to translate the consumer needs to target properties, right? Okay. So we have to do the feasible study, okay, before we can convert to the target properties. Okay. So only the expert would able to provide this knowledge. Okay, if necessary data is available. Okay. Okay. And then another option is we can as I told you previously, what is it? Publish article rights. Okay, another option we can collect the data from the published expert inside open source data okay, publish articles. This is what we can do and etc. Okay. Okay, to prepare the translation of need, this is we can use to prepare translation of needs to properties tables. Okay, so of course it's important we have to translate to the target properties. If not, we cannot use we cannot quantify and we cannot solve by using software or CMD. Okay, only by using software like a boiling point, right? That one is you can measure. Okay. So this is the identified characteristic of three type of liquids fuels from gasolines, jet fuels, and diesels. So left column is the need properties, and this one is the target properties. Ability to be burned. It must be related with the vapor pressure or distillation temperature. Okay, safety flashpoint. Okay, so if you look at here that gas, we can compare with between gasoline, jet fuel, and also diesel. So if you look at here that gasoline based products, the target properties is high rate vapor pressure. This is to ensure fuel is sufficiently vaporized to be burned. Okay, so meaning that the red one is the target properties. This is the and the black color is a need. Okay, okay. And then low viscosity, what is the need for the consumers? And then it must be stable, right? Should be evaporated easily, do not oxidize, and so on. Okay. How about the diesel based products, right? If you look at here that surrogate blends of diesel, a low rate vapor pressure, flash point high, low viscosity, low environmental impacts. Okay. So this is the target properties. Jet fuels, this is the red one is the target properties and the rest is the needs lah. Okay, which is quantitative and qualitative. Quantitative is the red one and qualitative is the red one. Okay. Okay, so this one is another example lubricant blends. Okay, if we blends between the fuels, so ability to lubricate and prevent wear. So meaning that is related with the viscosity and also friction. Okay, 4 points. Okay, flow at the ambient temperature. So meaning like a biodiesel, right? Actually is I think the 4 point for the biodiesel is very low. So that's why we cannot use this biodiesel at the very low temperature during the winter. Okay, it's related with the 4 points. Okay. Okay, so this is all the example about the needs and also the target properties, qualitative to the quantitative. Okay, so this is all the translation of the product needs to the targets properties for the lubricant blends. For example, this one, principal function or the goals: reduce resistance and prevent wear between two moving surface. Needs, this one. Okay, through knowledge-based literature search and legislation details. Must able to resist high temperature, density. Base oil also consider for the handling purpose. Okay, different upper and lower bonds. Okay. Okay. So actually the information that contained in the knowledge base is based on the order of the hierarchical system. Generally, if the on top of the hierarchicals, okay, on top is actually is a solvent base. Okay, this one. Okay, also, and then at the bottom generally is the like properties or like a temperature, pressure, composition is at the bottom, so we can divide it. Solvent, this one. Application type of the solvent base. Okay, and then at the bottom is the mostly on temperature, pressure is more to the properties. Okay, so this is like how to say flow chart lah. Okay, or tree diagram, right? This one. Okay, so this one we can have like essential properties, desired properties. Okay, EH and H for properties lah. So we can divide more. Okay. So if you look at here, the knowledge-based example, we can divide it into the essential properties, um, desirable properties, as well as EHS properties, right? This one. This one. There's something that we can measure. Okay. So what is essential properties, desirable properties, and EHS properties? Look at here that essentials. Okay, function of desired product. Okay. Example, molecule must be liquid state at temperature of the process. Okay. The requirement is the boiling point here. Okay, of the molecule more than the temperature melting point. Okay. So desirables, look at here that performance of efficiency of the product in the specified application. Okay. And then what else? Desirable, fixed lower to upper limits. Okay. And then EHS more to related to environment, health and safety. Right. The properties. What else? Maybe specified as essential, desirable, and the undesirables must be considered in the post design phase. Okay, must be from the beginnings. Okay. So this is all type of the properties. And for the solvent design, okay, the properties classification. Okay. So in designing the solvent also, actually we can classify, or we can divide it into the pure properties and also the mixture. Okay. So if you look at here that essential, right? Okay, mixture, essential and desirable. These are the properties, right? So we can divide it into mixture and the pure components. And then pure components we can divide it into primary, secondary, and also functionals dekat sini. Okay. So generally primary we can determine from the molecule structure variables. Okay, because it's a primary, right? And secondary actually is dependent on the properties lah. For example, like viscosity, solubility parameter, vapor pressure, and functionals actually is depending like depending on the pure components like temperature, pressure, okay, density, okay, that's the functionals. Okay, actually it's almost similar. Okay, but functionals is uh, pure component properties. This is from the pure components. Okay, and dependent on the temperature and also pressure. Okay, like liquid phase activities. Okay, vapor phase functions is functional, right? Okay, and some solubility is also from functionals. Okay, we can calculate from the primary properties, the functional, right? It's dependent on the primary also. Okay, and also can be dependent on the secondary properties. Okay, because the secondary can calculate it from the primary, right? Okay. Okay. So for the solvent design, so CMD problems, we have to specify the range of the conditions where the properties must be matched. Okay. Interval condition of the operation as a function of temperature, pressure, and also composition. Okay, so this is how you design the solvent. Okay, so if you look at here that for the crystallization, okay, class is property difference. Phase involves solid and liquid. Okay, so properties important to function in a particular application listed along relative property difference. Okay, so this one, the knowledge base of the properties, if you look at here that this is the class and also the separation technique lah. Okay, what the phase involved that we want to separate. Okay, if you look at here that crystallization is a method of the solid liquid lah. Distillation is vapor liquid. Okay, so this is just the knowledge how uh, to use the separation techniques. Okay, to separate between two components. Okay, or maybe like a liquid, right? Okay, what is the method, the separation technique? Okay, okay. And also like we have essential and desirable properties as a function of the application type. This must be related, right? Okay, like uh, if you look at here, that solid, liquid, vapor, liquid, vapor, liquid, vapor, liquid. This is the essential and desirable properties, right? So what is the properties involved? Like this one, delta, tau, mu, TB, boiling point, melting point. Rho is density, vapor pressure, enthalpy of vapor. Okay, for liquid, liquid. Essential is must be this one. Delta is I'm not sure. Boiling point, of course, liquid, liquid, and density. If you look at here, that isotrope, delta, boiling point, solid separation, boiling point, density lah, of course. Gas absorption more to related with the what is it, delta, tau, and mu. Delta, tau, and mu, I'm not sure it's a represent of what. I think coefficient activity got mu. Okay, so this is essential and also desirables. Okay, and this one is another examples, solid, liquid, SP. Okay, or for the mixture. Okay, so what is the desirable and also essential properties lah? Okay, for isotrope, this one is more to for the isotrope distillation. Extractive distillation is the isotrope. Okay, extractive distillations, we can use this unit operation to separate the isotrope, extractive distillation. Okay, okay. In terms of EHS properties, right? Okay, if you look at here, this is a general guidelines. Okay, the phase involved, like toxicity, reactivity, vapor pressure, okay, flash point. Okay, so if BOD is more to related with the environment side, right? BOD apa? Oxygen demand. Okay. If vapor, health and safety. Okay, because it can vaporize, right? Environmental concern. Okay. So that is EHS properties, and this one essential and desirable, the example. Okay. So that's all for today. Please look at the activity 3. If you look at here, that I give you about 5 minutes in your teams or maybe individuals, prepare a preliminary or mini knowledge base, okay, tables with need, properties, and the value based on the product that have been assigned to you during the problem formulation activity. Here are the product assignment for each team or individual. Hand sanitizer, air freshener, and hair cream. Submit through the link provided. Jamboard lah. So can you do the what is it, the needs, properties, and value lah? Okay, what is the needs and the properties? For example, just now hand sanitizer, right? So there's a solvent can be evaporate. What is the properties? Can you do now? The same link for the Jamboard. Go to next page. For the Jamboard, page 10. I give you 5 minutes. Before we stop. Please do need and properties and value if possible. Value is like if a boiling point 100 degrees or something like that. Maybe you can write needs. What is the need? And then properties. Needs is can evaporate at room temperature. Properties, boiling point. Values, 100 degrees C. Something like that. If possible lah, value is possible. If not possible, it's okay. This one you can do individual. Just before we stop, 5 minutes. This is just an introduction actually. So the main part is the molecular design, where we can use the ICAS to generate the candidate. And sanitizer, need properties. Laptop saya jadi slow lah. Air freshener, good fragrance. So I mean, how you measure these target properties? How you measure this one based on what good fragrance? Kill 199.9 germs. That one is needs. How about the properties? It needs to the properties. Needs we cannot measure. Okay, needs we cannot measure, right? This one. This one. Need goals and this is qualitative. Properties constraint is quantitative. Okay. Okay, maybe you can add also the constraint. For example, what is it? Air freshener. Air freshener, right? Target is to find the suitable molecule that give of strong and nice smell that will can stay long lah. Okay. Properties of course is a boiling point or flash point, and then the constraint maybe the other molecules or the solvents okay can evaporate quickly in the air, right? That one is like a air freshener. Okay, it's so too quick, right? Constraint. Maybe we can add the constraint here. Constraint. I think that's also good. Constraint. Constraint or value. Any constraint? What is the constraint? Flash point, no flavor, flash point, low boiling point, nitrogen ethanol alcohol. Still 99.9 germs ni, this is a needs, right? I think this is a needs. Ethanol. I think this is a value. This is need. What is related with the germs we can kill and sanitizer? I think it's more to pH lah. This is related to the pH, right? This is pH. Type of organic substance use, properties. This is how can we measure? Measure is something like this one. This one, right? Flash point, target properties. Density, melting point. Type of organic substance use. This one we can measure. I think this one can measure. This one. Non-flammable, yes, flash point. Type of chemical use. This one we can measure. This one. This one we can measure. Molecular size of the material used. Concentration of thickener. Concentration we related with what? Concentration. Concentration. Thickener. This one. So of course we concentration related with the viscosity lah. Concentration eh. Kinematic viscosity. Or friction coefficient. This one. Ability lubricate. This is we can measure. Like you use, have you ever used the, what is it? The Aspen-Hysis, right? How you insert the volume point. What else? The molar volume, that one is the something that we can measure. We can put as a measure. Okay, not something like we cannot measure. So boiling, of course, this one boiling point lah. Just a boiling point. Right. This is the example. If you look at here on the left side, right? This is the example. The left side. What is another example? This one. Safety, flash point. Engine efficiency, certain index, density, stability, miscibility. This one we can measure this one. If not, how can we input the information in the the value in the software? If you put just the concentration, friction coefficient, right? Constraint. Less than constraint is something like easily evaporate, right? And sanitizer maybe irritating to the skin. And sanitizer. This one, the constraint. The solvent is toxic to the human. That is a constraint. Okay. For example, it's 1 o'clock already. Thank you, thank you. That's all. Irritating to skin. Okay. This one we can bring here. Okay. So that's all for today. See you on Thursday. Okay. Thank you very much. So for those who still not scan the QR code, okay, tomorrow at next class we will I will explain about the molecular structure representation. Okay. So for those who still not scan the QR code, please scan. Okay. The one that I upload in the link is at 11 o'clock. This one is at 12 o'clock. Okay, thank you very much. See you guys.
Thank you, Rata.
Okay. Please scan the QR code.